So, good day. Thanks for the introduction. My name is Marin Crnković. I have around 10 years of experience, PHP developer mainly. And I work at web.burza, where we had this problem. We were developing on one central development server, and we started to step on each other's toes. What I mean by that is two guys would start to code on one single file. So when the first guy finished, the other guy would overwrite his changes. Also, that single development server had all possible PHP extensions because it had to support every project. Now, to find a solution, we opted to set up local development environments, and for that we use Vagrant. So Vagrant is a system that sets up the virtual machine in VirtualBox or other systems. But other than setting up a system, virtual machine, we also need to configure the virtual machine for each project. So how do you do that? So you could SSH to the box and then run a couple of commands, and then edit a couple of files. So okay, then you run a couple of more commands, and then you edit some more files. And by the time you're running commands and editing commands and running files, you tend to look for some other solution. So we developers, we tend to automate things. So why not automate setting up the server? And that's called the provisioning. Okay. So who are the big players in this field? We know that Puppet is the de facto standard. It came out in around 2005. It's written in Ruby, and its configuration is in Ruby. Puppet is the first system I started to use, but its configuration is really verbose, and the documentation was not that good at that time. I started to use it at 2011. So other than Puppet, we have Chef. Chef came out in 2009. It's also written in Ruby, and its configuration is also Ruby. Okay. Both those systems have great communities and are basically de facto standards of provisioning in DevOps world. In 2012 came Ansible. It's written in Python, and its configuration is in YAML. And SaltStack, a year later, before, in 2011, it's also written in Python, and its configuration is also in YAML, so there was a paradigm shift after 2010. Let's look at SaltStack. So what is SaltStack? What is SaltStack made of? So in SaltStack we have something called master. Master is a server who is controlling minions. Minions are those servers that you are provisioning. Minions run execution modules. Execution modules, we're going to talk about them later. We have state modules. State modules use execution modules to put a server in some state. And to configure, to write states, we would like to use variables. So, for example, Apache on Debian is called Apache 2. Apache on Red Hat-based systems is called HTTPD. So it's great to have a place for that variable, so we can write states agnostic to the name of the package. Next, we have grains. Now, pillars are variables that we write. Grains are variables that minions provide. So we have operating system name, memory, quantity, CPU, number of CPU cores, and such. Okay, this is a lot of stuff, so let's dive into each and every one. Okay. So nothing without Star Wars. Okay, a master is a main server. It keeps states, pillars, and top files. and it talks to minions via 0MQ or SSH or RAID. Now, 0MQ is a system that enables SaltStack to provision thousands of servers asynchronously. And next month there will be talk about 0MQ here, so I'm not going to go much into detail. SSH Transport is used for systems where you cannot install the minion. So, for example, routers, printers, and such. And there's this thing called RAID. Now, they're developing RAID because they have some issues with licensing, and they want to get even better speed, so they're building RAID. RAID is, I have it here written, it is asynchronous transport that aims to deliver much faster communication than 0MQ. Okay, next we have minions. Those are servers that master talks to, and master provides configuration to minions. Minions provide data about themselves, that's called grains. They listen to commands from master, and then they run execution modules. Okay, so how does master know what configuration to send to each of those minions? Master has top files. It has top file for states and top file for pillars, the variables. Okay, so top files describe environments, and they define set of states per minion, and also okay, and pillars have top file also. So we can see that here these are environments. The base environment gets every other environment gets inherits base. Now these are targets, so we are targeting every minion that's host name starts with app, and then this is the state that gets sent to that minion. Blah. Okay, states, they describe state, what to do. So a state is Apache needs to be installed. I'm not going to tell the system how it will install the Apache. I just want it to install Apache, that's it. And this is the way we write in configuration, in state configuration, the state. So Apache 2, its package needs to be installed, that's it. This is the short notation. We have verbose notation, so this is the name of the state. So install Apache, runs the package execution module. Execution module, we tell it to install, name Apache 2. Okay. Pillars are a set of variables for state configuration, and they also have their own top file. Grains are minion environment information. So, for example, operating system, I said that already, and you can write your own grains. So if you have something connected to your server, you can write your own grain that calls that service and reports back. Okay, this is now a configuration section. So configuration files in YAML, which is great. And they're written in Jinja templating engine, which is even greater because Jinja is Twig. So who is using Twig templating engine? Just one, two. Okay, I hoped for more. Because if you know Twig, you know how to set up SaltStack state configuration. There are other options to use, for example, JSON. You can write configuration in Python DSL or PyObjects, and more. And best of all, XML is not supported. Yeah. Okay, so let's take a look at some examples. How would you install Apache? So you tell master to target all the minions and install Apache to all the minions. Now, how do you install Apache? So this is just a state that gets sent to minion. That state is Apache, package installed, name Apache 2. We already saw this. Okay, next example. is pillars and grains. So, okay, Apache 2 won't work on Red Hat. So we have to say that we have to send a set of variables to Red Hat servers and set of variables to Debian-based servers. So this is the way we match the Debian or Red Hat servers. So we say, if you have operating system grain of Debian, then you get this pillar. If you have operating system grain of Red Hat, then you get Red Hat package pillar file. And each of these Red Hat packages or Debian packages have their variable set. So that enables us to write that aforementioned state in this way. So name is a variable. So now you have a SaltStack configuration that is agnostic to the name of the package. Okay. States can be extended and included. So you can write a state that installs Apache and write it once, and then include it and extend it for your purpose, specific purpose. So let's say that we have a website and we want to install a website on a minion. We would write a website configuration by a way to include the Apache install and then extend that Apache. So we have this service module. Service execution module is for running or resetting or stopping services. So after we install Apache, we tell it to run and to enable on boot. And this Apache install is the same state that we are using in this presentation up till now. Okay, so this is a whole example of installing Nginx. So let's say that we want to install Nginx, but we want to use their repository. So we can say, okay, state is this. For the name Nginx, manage with execution module package repo, manage and tell your package manager to put the Debian package in the apt repository. Then install this package, but we see here that we have something else. We have require. So the SaltStack runs in sequential order. So as we write it, SaltStack will execute it. But you could run into race condition. So this is the way to fix it. So this state will not run unless this has run first. So after we configure our package repository and install our package, we can also run our service. So service is running, we tell it to run, and then we have this watcher. Okay, what is a watcher? Watcher tells this execution module that it should restart the Nginx if ever package Nginx changes, or if file Nginx conf changes. So this is great if you're modifying your configuration file. You don't have to restart your service. These execution modules take care of that. Now I mentioned this file. Okay, so this file is just a name of this state. This is another state. This is Nginx state, and this is a file state. So we're telling it. Here we are telling that this file will be managed by us. Source of this file is on this root salt nginx conf. So SaltStack provides us the means to send files to our minions. And with this we said that our configuration is in Jinja. We're using template Jinja, so also our configuration files for Nginx is also Jinja, where we can also use variables. So for example, this is that configuration file where we say that the number of worker processes is 2 times the number of CPU cores. We don't know the number of CPU cores, the minion knows that, and he provides it with its grains. I think that 2 times the number of CPU cores is okay for the Nginx. If you have an opinion, you can share with me. Okay, so how do you run that? If you have a master server and it's connected to minions, you can say salt all the minions, put yourself into the high states. So they will then run all the state and configuration files that you sent. There is an option to run salt in masterless mode. So this is a masterless minion where everything is on that server. It doesn't talk to any master. And the command is simply almost the same. So we call salt call, state, high state, and with local option. Okay, so the conclusion of this talk would be that installing and configuring packages with SaltStack is easy because it's just writing files, YAML files. And starting and stopping services is also easy because we have watchers. And executing remote commands is also easy. We can execute commands by targeting specific minions or by running commands on all the minions. So that gives us the possibility to do something like deploy our code to all major cloud providers. So SaltStack provides something called Salt Cloud, and they have the implementation for Amazon Web Services, Linode, DigitalOcean, Rackspace, or all major cloud providers. So if you want to start up a new EC2 instance, you can do it with Salt. The other bit of conclusion is that configuration is just a bunch of files, so they can be versioned, and you can roll back your server to previous state just by running git commands, or you can fork the server. This GitHub repository holds the formulas, so they built state configurations for all major systems, so you can go there and see how Nginx or Elasticsearch or Sphinx or Node or Redis is set up. Okay, thank you for this opportunity. Any questions?
How's the community? How's the community?
The community is great. They are among the top 5 repository on GitHub. They have very fast response times on issues on GitHub, and they're constantly doing something with community. So, for example, this rate that they're developing, they developed that because of the community that wanted it. So ZeroMQ has some issues with cryptography, so they are building their own system to send MySQL passwords safely.
So how's the communication between nodes is not encrypted?
It is, but ZeroMQ has some problems with cryptography. So that is why they're building great.
Okay.
How to install Salt on Windows?
Yes, there is no way to do that. Minion can be installed on Windows, but master no.
Can you install master as Vagrant machine and then
Yes, that would be one inception way of doing this. Yeah.
Why did you decide on SaltStack and not Ssh Transport?
And not for?
How did you decide to go with SaltStack and not the other one?
I tried Puppet at first, and I really hardly tried to learn that, but I did manage to install the complete server, but it was just a lot of typing. And the Puppet has this form of classes, then it has manifests, blah, 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 blah. SaltStack only has these pre-configured execution modules that are very versatile in nature, so you don't need to configure everything by thousands of files.
How many servers are you managing with SaltStack?
The most I've managed is 5. So for one project that I'm using. And in that project I had minions that are database, minions that are application, and minions that are worker. So application had, code and PHP and whatever. The DB minions only had MySQL, and workers had only PHP without Apache. Anyone else? Thank you.